We will try to factor this sixth-degree polynomial using 3 different methods to find the correct path. In the first column, we group the first 2 terms, extracting the common factor x to the 4th. We transform the parenthesis into a difference of squares and separate the 2x squared into a sum. We apply difference of squares again in this second part, looking to create repeating factors. We group the binomials x plus 1 and x minus 1, using them as a large common factor. Unfortunately, we have an x squared adding at the end left over, so we mark this method as failed with an x. We move to the second column and try a new direction, extracting x squared from the first 3 terms. We immediately see that the minus 1 is completely isolated, so we also quickly discard this option. We resume our starting idea and apply the useful mathematical trick of adding 1 and subtracting 1. We operate the numbers, joining the negative 1 with the other negative 1 to form a minus 2. We factor out this number 2, leaving the expression x squared minus 1 inside a new parenthesis. We extract this parenthesis that repeats on both sides to multiply it by x to the 4th plus 2. However, we once again have a loose plus 1 at the end, preventing us from having a perfect factorization. Finally, in the third column, we try the definitive strategy that will lead us to the result. We extract a negative sign, grouping the last 3 terms and carefully inverting all their signs. We recall the powerful algebra formula of the perfect square binomial a minus b squared. We notice our parenthesis follows this rule, and we compress it to x squared minus 1, all raised to the square. We rewrite our initial x to the 6th as x cubed raised to the square to match the structures. We invoke our well-known difference of squares formula to destroy both outer exponents. We add and subtract both bases, victoriously arriving at the correct factored expression, marking it with the green check.